Hello once again, and we continue our cross-platform track today, and I'm really glad to welcome our next speaker, Ekaterina. Welcome.
Hey, welcome. Thanks for inviting me.
Katya is actually, she told me on the backstage that she joined JetBrains pretty recently, like 4 months ago, as a Kotlin developer advocate. So maybe you can tell us a little bit about how is to be a developer advocate. What was changed for your life?
The main change is that now I can't explain to my mom what I'm doing, because when I'm saying, hey mom, I'm a developer advocate, she's like, what advocate developer is something about legal stuff. So yeah, but I always was in love with mobile development, and I love to communicate with other developers, and so I think but now I just do what I love. So the changing is good.
So congratulations with that. That's the most important thing, to do what you love, actually. So let's have one more question, maybe a little bit tricky one, and we will proceed with the session itself. So if you were in a position, when you can choose the one single platform for every developer across the world, what it would be? iOS or Android?
Yeah, that's a tricky one, and I want to be honest, and I started my journey in IT, I don't remember, 9 or 10 years ago. Oh my God, I'm so old. And I started as an iOS developer, so I just can't choose Android, because I love iOS in my heart from the beginning, and I think for 10 years. But with KMM, I become closer and closer to Android, and so I think KMM will guide us to the perfect future where all platforms are together.
Okay, thank you so much. I guess it's okay to ask such questions on a cross-platform track. So whilst we are here, and I'd like to remind everybody who are listening to us that we are waiting. We really wait for your questions in Q&A section. And also, when the session is complete, you can leave your feedback for a speaker, or you can even go back to the previous speaker and leave feedback for him. So I guess we can start. It's time for Kotlin Multiplatform Mobile.
Yeah, thank you. So, hi again. My name is Kate, if you don't forget, and I'm a developer advocate for Kotlin. And at this talk, we're not going to spend much time discussing why you should try to make your applications cross-platform. Well, because we are on cross-platform track. So we've all known that reusing code is good, and that don't repeat yourself is the main principle on which a lot of architecture patterns are based, and it's because of many heated discussions in pull request comments. So one disclaimer. This talk is mostly an intro to development with Kotlin Multiplatform Mobile, or KMM, so it will be most useful for those of you who don't have much experience with this technology. But I hope that experienced KMM users would for them. For example, maybe ideas about how to introduce KMM and explain all its cool features to their team. So let's start and meet our main characters. This is Alex and Anne. They're in love with mobile development, but neither of them likes doing the same job twice. So today we will help Anne and Alex to take a journey into the wonderful world of cross-platform development, and we'll see how KMM will help them along the way. We'll look at all the different stages of mobile application development and learn how to use KMM features to optimize them. How do we usually proceed after we decide to stop duplicating the same code for different platforms? Of course, we start by comparing the existing solutions out there and looking for one that will best fit our needs, because the choice you make could greatly affect the architecture of our existing applications and any we create in the future. To understand the variety of options available, let's first take a look at the architecture of a standard mobile app. Basically, it consists of several layers: the UI, presentation layer, business layer, and data access layer. If we imagine a scale where the bottom point is core and the top point is UI, we can see that the most popular cross-platform approaches are UI-centric. What does it mean? Well, it doesn't mean that you can't write business logic code. Of course you can. It means that the whole ecosystem is focused mainly on developing UI components. But when you decide to write something more complicated than just sending HTTP requests, you will be almost alone in this wild west cross-platform world because of the lack of libraries and practices. However, these technologies allow you to create similar interfaces for your apps very quickly. So this approach is absolutely justified when you have simple apps, thin clients, or if you just want to make an MVP to test your product assumptions. But when your product starts to grow, UI quality and responsiveness requirements get stricter, and the business logic becomes too complicated for UI-centric approach. This is where the business logic-based approaches come in. We already have well-known players here, such as strategies to have shared C++ or JavaScript code. As always, they come with different advantages and disadvantages. One of the most harmful disadvantages is the need to add one more additional language to the existing code base, together with its own tooling, ecosystem, and rules. This doesn't seem like the easiest way to avoid duplicating just some parts of your code. So let's go back to Anne and Alex. Anne already has an existing project with complex logic, while Alex has just started to plan his new mobile app. But he has big ambitions for it, as all of us, and he doesn't want to find himself rewriting his entire application one day. So they both want to share only a specific part of their code, and they don't have time to learn a new language and deep dive into an unfamiliar ecosystem. Well, folks, good news for you. You can achieve this with Kotlin Multiplatform Mobile today. With Kotlin Multiplatform Mobile, Anne and Alex can immediately start sharing business logic between iOS and Android applications in any projects without any limitations on the UI development process and in their favorite language. So, sounds good, so let's have a look. Some of you, of course, may have heard about Kotlin Multiplatform or KMP. Some of you may have heard about Kotlin Native. To make sure we're all on the same page, let's make things clear and figure out what Kotlin Multiplatform Mobile is. Kotlin Multiplatform Mobile, or KMM, is an SDK for cross-platform mobile development. It uses the multi-platform capabilities of Kotlin and includes various tools and features designed to make the end-to-end experience of building mobile cross-platform applications efficient and enjoyable. KMM allows you to use a single code base for business logic of iOS and Android apps. You only need to write platform-specific code where it's necessary. For example, to implement a native UI or when working with platform-specific APIs. Whenever you want to use iOS or Android features, you can use the expect actual pattern to write platform-specific code with shared logic in the KMM module. KMM is seamlessly integrated with your mobile project. Shared code written in Kotlin is compiled to JVM bytecode with Kotlin JVM and to native binaries with Kotlin Native. So you can use your KMM business logic modules just like any other regular mobile library, and KMM doesn't impose any restrictions on how you develop your app's UI. So KMM equals Kotlin Multiplatform plus the mobile-specific stuff around it. What is the mobile-specific stuff? I think the best example is the new KMM plugin for Android Studio, which allows you to write, test, run, and debug shared code in the same IDE. But let's start from the beginning. Let's go through the development process of a typical mobile application and see how we can use KMM to make it cross-platform. But before I start speaking about app architecture, let's first figure out what kind of projects are suitable for integrating KMM. Alex is really lucky because he has a new project. It's always easier to speak about app architecture when we are going to create a new application. You have like a drawing board in front of you, and you can use whatever architecture you want and almost any kind of technologies as long as your company doesn't mind. But Anne already has a project, and she doesn't want to wait for a new one to start reusing code. So what about existing projects? Do we need to go back to the drawing board to start sharing code between platforms? Good news, no, you don't. As I said earlier, KMM is seamlessly integrated with any mobile project. Shared code written in Kotlin is compiled to JVM bytecode for Android and to native binaries for iOS, so you can use your KMM business logic modules just like any other regular mobile library. So technical details of KMM integration are the same in both new and existing projects, just adding new dependency. The only difference is in the process. For a new project, you can start developing new features in the shared code, then write native UI and connect it with your shared logic. And there are different strategies for integrating with an existing project. For example, you can take Kotlin code that has already been written for Android and refactor it by using only pure Kotlin libraries and make it compatible with iOS. Or you can take a new feature from the backlog, and then the process will be just the same as for a new project. So let's help Alex with his case. Alex loves space, so he wants to create a mobile application that will get information about SpaceX launches, store it in a local database, and display it in a list. Well, yes, a simple application, but as always, it's a big story. And as integration of KMM is always the same for both new and existing projects, and anyone else who wants to use KMM with an existing code base can easily use the same approaches. Okay, so we need to develop a typical mobile application that retrieves data from the API, displays it in a list, and caches it in a local database. On the first architecture design stage, we need to decide what parts will be shared and what parts will remain native. Let's go back to our architecture diagram. KMM is designed to allow you to share the business logic and core layers of your app. When we are creating a new mobile app, we don't want to spend a lot of time thinking about organizing the data layer. It's such a common task, and that there should definitely be some building blocks to do it quickly. And KMM provides exactly these building blocks. The ability to use platform-specific APIs along with the expect actual pattern allows you to create them without reinventing the wheel. The Ktor HTTP client is a good example of such a block. Like all multi-platform libraries, it provides several artifacts, one with common logic for all platforms, and drivers for different platforms, which allows you to use the platform's native capabilities to perform HTTP requests. The other building block we need is Kotlin serialization, which we will use to deserialize JSON responses into objects of entity classes. And the last one is SQLDelite. This will generate Kotlin code from SQL queries to create a type-safe database API, which we will use to communicate with databases on iOS and Android devices. As a Ktor library, besides the core artifact, SQLDelite also provides the platform-specific database drivers, one for Android and one for iOS. For the domain layer, let's add a couple of entities. In Alex's case, there should be entities for rockets and launches. And let's also add wrappers for Ktor and SQLDelite libraries that will allow us to get the data as business entities and hide some core details. The entry point to the KMM shared model will be the SpaceX SDK class, a facet over our networking and caching service. Now we have a mobile SDK, which could be used in our application. It also can be easily distributed as a separate mobile library to allow other developers to create clients for our web service, for example. This is a very simple KMM module architecture, but it's quite enough for Alex's purposes. And of course, you can create more layers of abstractions to make your code even cleaner. Now we are done with architecture, so let's figure out how we should configure our project. There are three main parts of any Kotlin multi-platform project: targets, source sets, and compilations. A target is a part of a build that is responsible for building, testing, and packaging the application for a specific platform. Source sets are collections of Kotlin code files along with their resources, dependencies, and language settings. A source set can be used in Kotlin compilations for one or more target platforms. Each target can have one or more compilations, for example, for production and test purposes. In our cross-platform mobile project, we need to declare two targets, obviously, Android and iOS. The common dependencies that are used in all targets need to be declared in the common source set. In our case, they are Ktor, Kotlin serialization, Ktor serialization feature, and the SQLite runtime. And since Kotlin 1.4 stdlib is added by default to any Kotlin Gradle project, there is no need to declare it explicitly. So you don't need to specify dependencies on different library variants in all source sets where it is used. You should specify a dependency on them only once in the shared source set. However, we still need to explicitly specify dependencies on Ktor engines and SQLite drivers because there are many of them, and it's impossible to determine automatically which of them to use. And this tiny iOS declaration hides some tricky KMM module configuration details for the iOS target. The thing is that the iOS simulator and iOS devices currently have different processor architectures. So to be able to run and test our app on both of them, we need to compile our shared code for two targets, not for one. Kotlin Multiplatform supports a hierarchical project structure that allows us to have an intermediate source set and use platform-specific APIs in them. In our case, this intermediate source set is iOS source set. But you don't really need to think about it while you're working on the shared code for your mobile apps. Everything just works out of the box with these two small declarations. So finally, configuration is finished. But before we start writing code, let's discuss our app architecture a little bit more. Well, I know for mobile developers, discussing different architectures is considered to be a hobby. Jokes aside, we've discussed core and business layers, but what about presentation? Do we need to share it or not? We definitely can do this, and there are already many community libraries that allow you to do this and have plenty of examples of their usage. But you need to think carefully. Do your apps look similar enough to have one presenter or view model or view controller for both of them? Could this change? I'll let you make that decision for yourself about your apps, and we will go with only shared business logic. After all, it's never too late to do some refactoring and move more layers to the shared module if you are sure that it's worth it. Our application architecture is now designed, and we know how to configure our project. Let's finally write some code and discover some KMM cool features. Of course, KMM is seamlessly integrated with Android. You use Kotlin for every part of your project and work in the same IDE, both for shared code and for platform code. But we are writing shared code for both platforms, and KMM also provides tight integration with the iOS development process. Thanks to Kotlin native bidirectional interoperability with Objective-C and Swift, you can call Kotlin code from Objective-C or Swift, and you can use iOS libraries from Kotlin. You can integrate KMM models in a natural way for iOS developers using the CocoaPods dependency manager. And you don't even need to switch IDEs while working on the shared code. With the new KMM Android Studio plugin, you can write, run, test, and debug shared code all in Android Studio on both platforms. Let's take a closer look at these features. Alex created a single function in the SDK class, which returns the list of launches from the database. So we can easily use our KMM module API in Swift. Kotlin's list is mapped to Swift array, so calling this function looks very natural. But before getting the cache data, we need to load it somehow. So we need to make an HTTP request. GetAllLaunches is a suspending function, so our public getLaunches functions need to be marked as suspending too. But there is no such concept in Objective-C or Swift. But you don't need to worry about it. Suspending functions are available in it as functions with callbacks. When you have such functions in the generated framework's header, you can call them from your Swift code or Objective-C code and even override them. Our HTTP client can throw an exception during the get_all_launches call. There is a fundamental difference in error handling between Kotlin and Swift. All Kotlin exceptions are unchecked, while Swift has only checked errors. Thus, to make Swift code aware of expected exceptions, Kotlin functions should be marked with a throws annotation specifying a list of potential exception classes as a parameter of this throws annotation. Now we can handle all exceptions in our completion handler in Swift code. This was just a small example of the Swift Objective-C interop possibilities. It supports all the fundamental concepts and doesn't require any additional setup, allowing you to integrate with KMM modules in iOS applications without a headache. Kotlin Native also provides integration with the CocoaPods dependency manager. You can use KMM modules as a CocoaPods dependency, or you can add dependencies on pod libraries stored locally or in the CocoaPods repository. You can manage pod dependencies directly in Android Studio, enjoying full coding support. And on the subject of Android Studio, with a new plugin, you can create a new KMM project or modules with just a few clicks, and you get the integration with your iOS device and simulator directly in Android Studio. With a new Kotlin Multiplatform Mobile project wizard, you can create a ready-to-run mobile application project with a shared codebase in just a few clicks. The generated project will contain examples of how to connect to platform-specific APIs and basic test coverage. You can use this wizard to explore the basic features of KMM or as a scaffolding tool for your new KMM production applications. And I'm sure this wizard will help Alex start developing KMM applications much faster. And you no longer need to switch IDEs and have Xcode running to check that your code works correctly on both mobile platforms. You can run and debug the iOS application on the simulator or a device with a predefined run configuration. You can run and debug common and iOS-specific tests on the iOS simulator by simply clicking the gutter icon on a test class or method. And for both the application and tests, you can set breakpoints and debug your code on iOS. After writing our code, we want to test and deploy it, obviously. You'll be glad to hear that there are no big differences in this process, as your shared code is connected like any other regular dependency. One difference, if you want to optimize your manual QA work right now, is that because the business logic code is reused and you don't need to test some features on both platforms, and you can only do it once. Congratulations! We've designed the architecture of our app, created a project with the KMM plugins wizard, written some code in Kotlin, and integrated it into both our iOS and Android applications. You can find the complete project with a step-by-step tutorial at our hands-on portal and use it as a guide to creating your KMM application. Alex and Anne looks really happy because now they definitely know how to stop duplicating code for mobile platforms, and they've learned that it's definitely time for Kotlin Multiplatform Mobile. And everything sounds great at this stage, but you know, a lot of such talks usually feel like a draw-and-all story. Everything is easy on the first step, but when you want to create something more complex than basic examples, then everything becomes not so smooth. Of course, you will meet some obstacles on the way of integrating KMM, if your project is rather complex and team is rather big. But in my experience, it's a common thing for any kind of technology. Based on my experience and the experience of lots of KMM adopters, these are the most popular obstacles that the mobile team faces. Some of them are technical, such as differences between JVM and native worlds, Objective-C and Swift interoperability issues, and Kotlin native compile time. As you see, they all related to the native development with Kotlin, and I think it's quite expectable because Kotlin was originally developed as JVM-based language, so integration with Android world is smooth out of the box. You could also face an organizing team challenge, which is more process-like, and it's usual thing when you're integrating new technology into your code base if you are working in a team. But forewarned is forearmed. So let's go through these challenges and see how Kotlin team addresses these issues and what you can do to overcome them right now. When we speak about Kotlin multi-platform programming, here is a tricky thing. It's the same and not the same Kotlin at the same time. It uses different compiler backends under the hood to be able to run Kotlin code both on JVM and on native platforms. That's why the realization and behavior of some things could be different. And the most vivid example is the memory model realization. It greatly affects the experience of working with concurrency. For example, your code can work perfectly on Android while you will get invalid mutability exception on iOS. And it could scare you a little bit, especially when you have no idea what's going on and what is under the hood. So how to overcome these challenges? I suggest you learn some basics at our new documentation portal. It's much easier to work with Kotlin native concurrency when you understand how it works. There is a set of articles describing Kotlin native concurrency rules, how to work with them, and also suggests different approaches how to work with concurrent code in KMM project. One of them is to try to manage concurrency only in the shared code and make calls to the KMM library only from the main thread from your iOS or Android code. If you combine this approach with using the concurrency libraries, such as Kotlin X coroutines library, you would avoid the majority of potential problems and everything will work smooth. To use coroutines on multiple threads in a native world, currently you need to use a special version of a library. This special version is living in a separate branch of the coroutines repository. It may look strange, but it's safe to use it in your project because it will get continuous support until Kotlin team implements the new Kotlin native memory management model. Because now using multi-threaded coroutines may result in memory leaks sometimes. This can be a problem for very complex coroutine scenarios under load. So a new Kotlin native memory management model is on the roadmap, and team is working on a solution for this right now. The next obstacle some users face is some unexpected things about how interoperability with Swift and Objective-C works. Some of the usual complaints are how enums and sealed classes are represented in the generated declarations, and, for example, that there is no default argument support and some issues with primitives. And my first advice here is to be ready. At a first glance, Kotlin and Swift looks very similar, and you expect that you will be able to work with every Kotlin construction in Swift as usual. For example, I was very surprised when I created a companion object with a single function in it in my Kotlin code, and I didn't find a corresponding class member or static function in generated Objective-C headers. But when I realized that it's reasonable because companion objects are objects and they can, for example, implement interfaces. So this doesn't seem correct to unconditionally export all object members as class members. Another example of fundamental differences between Kotlin and Swift is exception handling, which I mentioned earlier. So when you realize these differences, it becomes easier to handle it. If you're using a language feature and there is no such concept in Swift, you simply can create wrappers in your shared Kotlin code. For example, before Kotlin 1.4, suspend functions weren't supported in Kotlin native interoperability with Swift or Objective-C, but it doesn't mean you weren't able to use it. You could create a simple wrapper function for them. And since 1.4, the support of suspending function is built in. And if you don't like the generated Objective-C declarations and you want your code to be more Swifty, you could create a wrapper module, a wrapper Swift module using the adapter pattern. Of course, this approach comes with the need of writing extra code, but your shared module API will look as you want, and other developers may even don't know that they're using a Kotlin library under the hood. So the choice is yours. And as you can see, improving exporting Kotlin code to Objective-C, which will improve Swift interop through Objective-C, is one of the goals for the Kotlin next version. The next potential issue is Kotlin native compile time. It can become a serious problem if your project is rather big and your development process includes a lot of small iterations of modifying shared code and building it for running on iOS. You can minimize this negative effect of this by using some practices to decrease the number of rebuilding apps for checking if it works correctly on iOS. For example, there are already a lot of useful multi-platform libraries, for example, Napier logging library. Comprehensive logs with different levels would help you to debug your application quickly. And please use the benefits of code reuse. You can run and debug your code on Android because, well, it's the same code, except some corner cases, such as working with concurrency, which I mentioned earlier. For such cases, having tests for common code would be very helpful. You can run them both on both platforms on pull requests, for example. Kotlin team is working hard on this issue, and optimizing the compile time is on the top of Kotlin native team backlog. And organizing the team can also be challenging, as software development is a team game, with each critical decision needing the approval of all team members. And integrating any cross-platform technology will, of course, significantly affect the development process of your mobile application. So before you start integrating Kotlin Multiplatform Mobile in your project, you'll need to introduce your team to the technology and guide them gently to see it's worth adopting. On our new documentation portal, we have a special article with some recommendations on how to do it. For example, how to get rid of any pre-existing bad feelings about cross-platform applications, and how to provide continuous support for your teammates during the adaptation period. To start using KMM in your team, you need to answer some organization questions. For example, who will be responsible for the shared code? Who will be the code owner? It will be Android part of the team or iOS part of the team or both of them. Or there the shared code will be stored. It will be monorepo or many repos for the projects. Who knows? So the main advice of our adopters: integrate KMM gradually as it allows it. You can start with a small new feature or by using it in the new internal product, for example. This will allow you not to stuck with lots of unanswered questions and will give you time to make decisions carefully. And a good source of knowledge and inspiration for such kinds of decisions is the first-hand experience of KMM production users. On our documentation portal, you can find not only the list of the teams, but also their stories about how KMM is used in their product and what profits and gains they have experienced since adopting Kotlin Multiplatform. We saw what challenges you may face on your way of integrating KMM, but don't be afraid. Kotlin team is working hard to make KMM users' life better, and you won't be alone. Community have been successfully overcoming these challenges and share their experience all the time. So, why today is a good day to start? KMM is now in alpha. This means that the Kotlin team is fully committed to improving this technology and helping it evolve. It's also a signal that the product will develop quickly from here now. Going alpha means that everything is ready for you to start using KMM to share business logic code between mobile platforms. You can create a new project or easily integrate the KMM module into existing ones. And in both scenarios, the work can be done with minimal cost and you can always go back to fully native development. And the community is growing fast, so you can influence the development of a whole ecosystem by participating in it. What's the best way to start? The new KMM developer portal, which I mentioned many times today, is your trusted resource when you're working with KMM. You will find content for all levels of expertise, from tutorials to get you started to more advanced development topics. It contains useful information about common tasks like organizing networking and data storage layers, and even organizing the development process around KMM. Looking for new ideas about the benefits of using KMM in your application? Learn from a first-hand experience of a variety of teams, for example, VMware, Quizlet, and Yandex, who are already using KMM in their products in the case study section, and try the new KMM plugin. With a new wizards and iOS integration, you can create a new KMM project just in a few clicks and start exploring all the KMM features. Thank you, and have a nice Kotlin.
Thanks a lot. Catherine, I guess. Thanks a lot. You have a nice name. Okay, it's time for questions, and we'll have some of the questions. So, Kate, if you want to read questions easily, you can just switch to Q&A section in chat, and I will voice some of them. So the first one is there a recommended architecture pattern when you're using KMM?
Good question. Thanks for it. I think the best thing about KMM that it's very flexible, and as I said, you can share as many layers as you want. So the best pattern, it's not an architecture pattern, it's just with solid principles to make your code clean, and then you can use any of this mobile famous pattern, for example, EVM pattern, MVP pattern, MVI pattern, or Redux architecture. So everything works because, as I said, KMM focus mainly on sharing business logic and core layers, and that's why you can connect this shared model to any kind of architecture.
That's super, actually. Let's read the next question. With the Objective-C with coroutines and flows, how do you handle the life cycle? For example, in Android side, you would use a coroutine scope tied to the activity life cycle. So is there equivalent for an iOS?
Yeah, also, thanks the audience for good questions. I think the best advice is to, as I mentioned, there is one approach to handle all concurrency story in the shared code. So you don't need to use something about flow on the iOS side. So I'm not sure I've answered fully on this question, and we can just continue the discussion in Slack, and I can just share some sample projects of different approaches for it.
Okay. By the way, right after this session, we will have the panel discussion, and at the same time, if you have bought a ticket, you will have an access to special team, to special room with a chat where you can continue talk with the different speakers during and after the whole conference. So let's voice one more question, okay? I actually like it's very short, and I actually like it. If I would want to add the web version later, can you do that on KMM project?
Yes, also a good one. I think this conference is a winner for the good questions about web version. If you have heard about Kotlin Multiplatform before, you may know that Kotlin Multiplatform also supports another target. It's JavaScript target. So you are able to compile your Kotlin code also to JavaScript and use it for the web version of your applications. KMM is just a name to combine all the technologies that allows mobile developers create cross-platform mobile applications, but it doesn't mean that you can't just add another JS target to your Gradle build file, and you then will have a new artifact which is suitable to using for web version. But I think maybe you would face some obstacles if you're speaking about tooling when you're working with Kotlin.js, but that's out of the scope of this discussion. and we also can discuss it later.
Okay, thanks a lot, Kate, and thanks a lot all the audience. So you really had a great question. So we still have about 4 not answered questions. And Kate, if you will be able, please talk with people in chat so you can answer at least some of them, okay? And what's going on next? In about 5 minutes, we will start a panel discussion about the future of mobile development. The discussion will take place on Android track. And apart from that, again, if you buy a ticket, you have access to Special, which is a kind of chat room where you can move your head icon and join any other group of people or conversations to listen or ask your questions and so on and so forth. So please join it and have fun there. And the last announcement, right after the panel discussion is over, in 18:20, we will have the next talk, Axel Rost, about a very interesting topic, actually, about embedded Arduino platform and how to work with it just with a pure Swift. So IoT with a full IoT solution with pure Swift. So join us. It will be really interesting. And Kate, once again, thanks a lot for the great talk and answering the interesting questions.
Thank you.
Yeah. And once again, audience, thanks a lot. It's so nice when the audience is so active and we have nice questions. See you later.